Next, let's talk about fleet networking. There are two ways of communicating between Anthos clusters, and in most cases, you will be using both approaches. North-south routing handles the communication from a load balancer into our clusters. That load balancer can be receiving traffic from the internet or from some internal applications. East-west routing handles the communication between clusters. This is important for use cases such as having dependencies in other clusters, implementing fallback strategies, or performing blue-green deployments. In this module, we'll talk about north-south routing. We discussed east-west routing together with Anthos Service Mesh in a different module. Google provides support for ingressing clusters through Google-managed cloud load balancers. You can use network endpoint groups to send data outside of Google Cloud with a global external HTTPS load balancers, internal HTTPS load balancers, TCP proxy load balancers, and SSL proxy load balancers. Regional external HTTPS load balancers don't support load balancing outside of Google Cloud. We will talk more about network endpoint groups in a moment. There are many reasons why companies choose to run multiple clusters in Google Cloud. The reasons are classified based on location and isolation needs. For example, companies choose to have clusters in different locations to be close to their customers so that they can serve traffic with minimum latencies, increase availability by continuing to provide support after a region is unavailable, be in the same jurisdiction as their customers to fill compliance requirements, have the compute close to the data so that they can minimize data transfer costs and increase computational speed. In addition, companies choose to have multiple clusters to guarantee isolation when they want to have separate environments such as development and production workloads in different clusters, split workloads into different categories, reduce impact from failure, provide upgrades without reducing availability, provide compliance and regulatory separation of clients, data, applications, etc. Multi-cluster networking is available in Google Cloud by combining different technologies. A single Anycast IP address can be deployed to multiple regions and routed based on proximity to the user. Global HTTPS load balancers use Anycast IPs to receive traffic and route the request to the nearest cluster. Google's Premium Network offers cold potato routing to Google POPs and hot potato routing inside Google's network. Once we are in Google's network, the Global HTTPS load balancer uses network endpoint groups, or NEGs, to send traffic to dynamically configured endpoints. NEGs can send traffic to serverless offerings like Cloud Functions or Cloud Run, primary IPs like Compute Engine Virtual Machines, secondary IPs like pods on Kubernetes for container-native load balancing. How do we make pods discoverable in Kubernetes? 1. Service B is defined with a service object in etcd. 2. The service B definition includes a selector, and based on that selector, the top 3 pods are identified as endpoints. The endpoints object in etcd contains the IP addresses for the pods that sit behind service B. The kubelet agent on each node uses the endpoint's information to update IP tables so that outgoing connections to 10.70.0.11 get rewritten and sent to one of the pod IP addresses. 5. Most Kubernetes clusters will have a DNS server workload running in the control plane, exposed to a DNS service. 6. If the bottom pod wants to establish a connection with the service B pod, it will first perform a DNS lookup on the service name. For example, serviceb.default.cluster-domain.local. 7. Once it gets the VIP for service B, it attempts to connect to that service IP. and IP tables will rewrite the packet and send to a service B pod IP. 8. Service discovery, and ultimately request routing, is handled entirely within the cluster. What if you want a service that runs on multiple clusters, and you want pods within any of the clusters to have requests to multi-cluster services to be load balanced across clusters?